Okay. All right, so I told you to start with a line, right? What did you do first?
Pick a point.
Pick a point on the line.
Call it point A. Point
And we call it A.
Then what?
Use the protractor and draw a circle.
Draw a circle. What about the circle?
Center it at A.
Doesn't matter what size it is.
Has to be the same size, sir.
Same size as what? There's nothing else on here.
I thought.
All right, draw a circle centered at A.
Pick a point at the edge of the circle.
Where? Here?
No, on the line.
Choose a point.
On the line. On the
Choose points B and C where
circle
the
intersect the line.
circle intersects the line. All right. So we have B and C. Now what?
And then draw a circle centered at C.
What do y'all think? Should we draw a circle centered at C?
No, it's a draw a circle. No. Yeah, draw a circle centered at.
Does it matter what size it is?
Yes, it has to be the same size as A and C. The radius as radius AC.
Are you sure?
AB, AC.
I think it can be a different size.
I thought it was the same size.
First one was given point A.
Uh-huh.
Now, what's the radius of it?
It doesn't matter. Oops, I drew it centered at B instead of C. All right, so I drew a circle centered at B. Now what?
You need to draw a circle centered at C.
What? With the same radius as circle B. That is important. Maybe. Yes. You do have to draw three circles.
You did? You didn't draw 3 circles yesterday.
I know, but when we get to our explanation, we need that first circle.
Draw a line.
Well, how do you?
B and C circles intersect that.
So what do you draw?
Choose points. What?
To get B and C,
Uh-huh.
did you just pick a point, or what did you use?
I picked point A,
Yes.
and I drew a circle centered at A. And then where the circle intersects the line, I picked B and C.
Oh.
Choose points D and E where?
Where the circle of B and C circles intersect with each other.
Okay. So I have a point here. That's D. And a point here. That's E.
And then you connect line.
Then what?
Connect
Draw line
D.
DE.
And did you just make? You just used a different size to make those circles.
Here's your writing.
Circle B, it doesn't matter how big it is, but circle C has to be the same size.
Okay.
Now, we can't let them be too small because then they wouldn't intersect.
Yeah.
If we made them the same size as circle A, then they would intersect only at that one point, and we wouldn't have 2 points to draw it through, which is why I made it bigger than the circle around A. Does that make sense to everybody?
Yes.
Okay, so we want these circles to overlap, and we want them to overlap twice instead of just touch in one spot. All right, so here's the tricky part. We need to explain it.
Oh, darn.
All right, explanation.
We started off and we put like,
Okay, before we get to the explanation, let's think about what we want the last thing to say. So what was the purpose of doing this problem? What did it ask for us to do?
Right angle.
Construct a right angle. So before we can say this is a right angle, we need to know what right angle means. What does right angle mean?
congruent.
An angle congruent to its supplement. Do we have any supplementary angles on the board? Angle BAD, what is its supplement?
Angle
BC.
B.
BAD, what is its supplement?
Its supplement is, isn't it DAC?
DAC is its supplement. Okay? So I'm going to say angle BAD and angle DAC are supplements by definition. Angle BAD, angle DAC are supplements by definition. Now we're going to need to use that when we want to say that it's congruent to its supplement, right? We have to say that they're supplements first. All right, now we need to show that this angle is congruent to this angle because that's what right angle means. If they're congruent to each other, then it's a right angle, right? That's the definition. So how can we show that angle BAD is congruent to angle DAC? Look back at problem 23. Did we show that two angles were congruent in problem 23? Yes, we did. So let's use those ideas. What do we know from, what can you tell me about segment BA and segment AC? BA is congruent
Yes.
to AC. Why?
Because they are radiuses of the same circle.
Right, by definition of radius. They're both radii of the same circle, so they are congruent to each other. All right, what else can we say? We're looking at this angle. So remember how we used triangles in our proof for 23? Do you remember that? What triangles are we going to look at here?
The one in the circle.
The ones on the end,
Triangle BAD and triangle
DAC.
DAC, right? So far I've shown that segment AB is congruent to segment AC. What else do I need to say?
And then you can say,
Here's this triangle. And here is this triangle.
when you say there's something supplement,
We've already said something about being supplements.
okay.
I thought we were just trying to get a right angle. I didn't know we were drawing like triangles too.
Well, we have to prove that the angle is a right angle.
You'll say B and D is congruent to D and C
All right, BD is congruent to DC. Why?
because definition of radius.
Because they are radii of congruent circles. They're radii of congruent circles. Okay, so now we've said that BD is congruent to DC. We have one more thing left to say. We've got one side congruent to one side, A second side congruent to a second side.
Third side.
What about the third side? What is the third side?
Would it be BC?
What's the third side of the triangle?
Okay, 1, 2, 3 points.
DA. What can we say about DA?
DA is congruent to DA.
Why?
That's what
Do you remember that name? R. Reflexive property. All right, so now we've said that this side is congruent to itself. So what can we say about these two triangles? They're congruent. Why? Triangle BAD is congruent to what?
It's congruent to D.
it's congruent to AC. No, DAC.
Is it DAC? CAD? Remember, order matters. Why? Why is it congruent?
It's all the same side.
By, what about all the same sides?
Side,
Axiom
side.
2. Side, side, side. Good. I'm going to put my little triangle symbols here. Triangle BAD is congruent to triangle CAD. Alright, so we've said the two triangles are congruent. That's not what we wanted to end with here, though. What do we want to end with?
A very simple.
We just said at the beginning, before we started the explanation, what do we want to end with?
Angle BAD is congruent to angle CAD.
Angle BAD is congruent to angle CAD because that's its supplement, right?
By CPCFC.
Right. So angle BAD is congruent to angle CAD by CPCFC. Congruent, corresponding parts of congruent figures are congruent. All right. Now, are BAD and CAD supplements? Are BAD and CAD supplements? Is angle BAD and angle CAD, are they supplementary angles? Yes, we said that in the first line. So since they're congruent and they're supplements, what can we say about those two angles?
That they are congruent.
No, we already said they're congruent.
Okay, so we got this down.
Yeah.
What can we say since they are congruent?
They, therefore,
But they all make triangles.
right angle.
Right. Therefore, angle BAD is a right angle.
But I didn't know they want us to know that the BAD, the angle BAD was right angle.
What did the question ask for you to do?
Correct. I thought.
Construct a right angle. We got one right here.
You said we have 4.
Well, we do have 4, but we only needed 1. Does that make sense? Does anyone have questions? It is a lot to write down. It is a lot to remember. But a lot of this is very similar to problem 23. All right, we're going to be using triangles a lot to prove things are congruent. Triangles are really the foundation of everything. Triangles are the strongest structurally. Yeah. Yeah. Not squares. Squares can collapse. But if you put a bracket through a square and turn it into a triangle, it won't.
Yeah.